All right, we're going to talk about Arrhenius acids and bases, section 20.2. And our objective is to be able to define Arrhenius acids and list some substances, and same thing with bases. So take a look at these equations here. If you take a look at all these HCl yields H plus Cl and so on, take a look at all of the first three. You'll notice they all have hydrogens, give you H pluses, and you'll notice on the last two they give you OH minuses. And if we look at Arrhenius acids, and this is kind of the smallest, narrowest definition of an acid, and we'll get to some broader ones later on, but an Arrhenius acid is one where they produce hydrogen ions. So you see you've got the hydrogen ions. That's considered an Arrhenius acid. So these would be examples right there. So far, everything that you know about naming and all those things, those would all be considered Arrhenius acids. Arrhenius bases give us hydroxides. Once again, the narrowest definition of an acid is the Arrhenius acids and bases, or narrowest definition of a base here. Okay, so bases, if the name would have hydroxide in it, then we know it's going to be a base. So if you have sodium hydroxide, magnesium hydroxide, those are going to be bases. And hydrogen, usually if with an acid it starts with hydrogen. It's not always, depends on how they write some of these things. Some of the organic acids, they'll put the hydrogen at the end. But most everything that we'll do, the hydrogens will be at the beginning. Now I want to talk just a little bit about strengths of acids and bases. We've done some of this probably already. So we're going to go over just a little bit. And this is just the one part. We're only doing like the first 2 pages in section 4. We're not going to do the other stuff. And just be able to tell me the difference between strong and a weak acid, and specify, identify some specific acids as either strong or weak, and define. All right, so first of all, strong acids and strong bases are ones that completely dissociate, or they dissolve completely when you put them in water. So if you look at this, we've got some hydrochloric acid, put it in water, you get all of these H3O pluses, and you get a Cl minus. Now, a lot of times we just write this, I've just done this, H plus Cl minus. All they've done is said, hey, well, let's make it with the water. And when you have water, you would add that water into the hydrogen, and you get what's called the hydronium ion, like that. But basically what we're saying is everything, 100% of this becomes this over here. And because there are a lot of ions, these are good conductors of electricity. Here is our formula, or our list of strong acids, and you should be familiar with these. Notice that there's 6 of them: hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, and sulfuric. 6 strong acids. Okay, make sure you know those. Weak acids or weak bases, these are ones that don't completely dissociate. So when I put them in, a lot of them just stay as the original thing. They don't dissolve. And I don't know, dissolve is probably not really a good word. They just don't break up into those different ions. Therefore, there's usually fewer hydrogen ions in the solution. So if I have this, and usually they use a little kind of a double arrow like that to indicate this, you know what happens is the majority of it stays this. Maybe that's 95% or whatever, and only 5% becomes these things over here. You know, or maybe some things are far less than 1%, just depends. All right, so what I want you to do is write the dissociation equations for the weak acids, only the weak ones below. So stop the video and do that. All right, so hopefully when you do that, you say, oh, I don't have to do sulfuric because that's a strong acid, so I do hydrofluoric. If I put it in water, I'm going to get this H3O plus F minus. That's that constant. Okay, so for the trichloroacetic acid, okay, notice that this one's kind of weird, and this is where the hydrogen's at the end. And this is still an acid, but you would get this CCl3COOH plus H2O. It's going to give me H3O plus plus CCl3COO minus. And there you have it. That's the end of those two sections.